In this lesson, we're going to discuss cross-site scripting and cross-site request forgery attacks. Now, cross-site scripting is a malicious script that's hosted on an attacker's site or coded inside of a link that's injected into a trusted site designed to compromise the client that is browsing that trusted site. Now, this allows the attacker to circumvent the browser security model or trusted zones. And the attacker's goal in using cross-site scripting is to get you to run some kind of malicious script so that your system will process this thing and bypass its normal security mechanisms. Cross-site scripting is a powerful exploit that relies on your website not conducting proper input validation. If you're not doing proper input validation, you are most likely going to fall victim to a cross-site scripting attack. So let's take a look at how cross-site scripting works in the real world by looking at the 4 basic steps of a cross-site scripting attack. First, the attacker identifies an input validation vulnerability within a trusted website. For example, if my website doesn't conduct proper input validation for the username and password fields used by my students, that could become a good candidate for cross-site scripting attacks. Second, the attacker crafts a URL to perform the code injection against that trusted website. At the same time, the attacker needs to get somebody to click on that maliciously encoded URL. So they might post it to a trusted website, embed it in an email message using a phishing campaign, or post it to an online forum. The goal here is that the attacker needs to get somebody to click on that encoded URL. Third, the trusted site will return a page containing the malicious code injected as well as the regular site code. This occurs once the user clicks the encoded URL and the trusted site executes the code that was injected. At this point, the user is going to be presented with malicious content, which they believe is trusted because it came from the trusted website that they were visiting. Fourth, the malicious code is now run in the client's browser, finalizing the cross-site scripting attack. When this occurs, the code will run the permission level of the trusted site because the system believes the trusted site sent that code, which technically it did because it was injected into the reply coming from that trusted server to the end user's browser. This is why we call it a cross-site scripting attack, because malicious code is actually going to be injected and served by the trusted site to their users. Now, for example, let's say I was scrolling Facebook and somebody was able to perform a cross-site scripting attack there, and they could inject code into my newsfeed. Now, it's going to cross that threat actor site into the trusted site, in this case Facebook, and then it's delivered to me, the end user who's scrolling my newsfeed. That's how a cross-site scripting attack works. Now, cross-site scripting attacks can be used to run malicious code that perform many different functions. One attack may focus on defacing the trusted website by injecting extra HTML code into it. Another attack might focus on stealing the user's data by stealing protected cookies from that user. Another might try to intercept data or communications as they're being entered into the web forms. And yet another might try to install malware on your client system. As you can imagine, there are lots of different things we can do with the malicious code being run, but cross-site scripting is the initial delivery mechanism that the threat actor is going to use to get that malicious code to your system and have it run by your web browser. Now, the reason cross-site scripting is so dangerous is because it breaks the browser security and trust model, because browsers are going to assume that scripts it receives from a trusted site should be safe to run. Now, this isn't the browser's fault, it's just because they're designed to run scripts they receive from trusted sites. That's how the internet is designed. After all, if you go to my website, there are lots of different scripts we're running in order to provide you with the training videos, quizzes, and practice exams that you want. Your browser knows that it can trust my website because it has a valid digital certificate and you've logged into our site, and therefore you're a trusted client and we're a trusted site. Without this level of trust, web pages would be extremely boring because no scripts could ever be run or operated. So let's take a quick look at what cross-site scripting might look like if we used it against a vulnerable website. First, we're going to craft the URL by adding the script to an otherwise safe URL. For example, if my site was vulnerable, we could use a URL like deontraining.com/search?Q equals, and then you'll see something like bracket script %20 type equals quote application/JavaScript end quote bracket alert parentheses XSX parentheses bracket/script bracket. Now, what does this really say? Well, the first part here is simply saying we're going to use a trusted website like deontraining.com. The next part that says search?Q equals would normally be used for a website to conduct a search for anything found after the Q equals, because that is my query. For example, maybe you're on my site and you're searching for the word CompTIA, so you would see in the URL Q equals CompTIA, and that would send the word CompTIA to my server to be able to search its database for any pages that have the word CompTIA in it. Now, because we're attempting a cross-site scripting attack here, we're actually going to replace the query with the script that we want to insert. In this case, I have a really short piece of JavaScript code that's going to pop up an alert box that says XSS when it goes and reaches the server. Now, if you try to run this code, it probably won't work on my website because my site is already protected from this type of cross-site scripting attack. But if you want to attempt these on your own, you could check out the cross-site scripting game set up by Google at xss-game.appspot.com, which has 6 different challenges where you try to create a cross-site scripting attack against their servers. The first one can be completed using the example I just covered in this lesson. Now, the example I just showed you is what's known as a reflected or non-persistent cross-site scripting attack. This type of attack only occurs when it's launched because you're clicking on that link or you're entering it into your web browser and pressing enter. When it happens once and then it stops because it is considered non-persistent. Now, there are other types of cross-site scripting attacks though, and these can be more dangerous. For example, a persistent cross-site scripting attack allows an attacker to insert code into the backend database used by that trusted website. By doing this, the attacker doesn't have to wait for somebody to actually click on a link anymore because the malicious code is now embedded into that website's database. Anytime a user loads the page or content from the database, they're going to be loading the persistent cross-site script as well. Now, both persistent and non-persistent cross-site scripting attacks are considered forms of server-side scripting attacks because it's the server that is executing the scripts that we're injecting. Now, there's also a client-side attack known as a DOM cross-site scripting attack. Now, DOM, or DOM, is the Document Object Model, and the Document Object Model cross-site scripting attack is going to exploit the client's web browser using client-side scripts to modify the content and layout of the web page. The Document Object Model, or DOM, is how things are displayed in the client's browser, but by injecting scripts into the DOM, you can actually change this. Now, let me show you a quick example of a DOM-based cross-site scripting attack. In this simple example, you can see a URL of deontraining.com/index.html, #default equals script alert document.cookie script. Now, at first glance, this looks a lot like the non-persistent cross-site scripting attack that I showed you earlier, and both of these do have a short script and an alert being issued. But the big difference with this one is actually in the payload itself, because we're using the alert to show the contents of document.cookie. Now, when you see the word document here, this is an indication that we're looking at the DOM, or the Document Object Model, inside of the web browser. In this example, we're trying to access the cookie stored inside of the web browser's DOM, and therefore, we're trying to execute this in the browser and display the contents of those clients' cookies. If the web browser is vulnerable to this, you're going to then see code go, oh, I see this code, you're asking for document.cookie. You want to see what my cookies are? Well, let me show you, and we'll display those cookies to the screen using this alert. This again is a simple example, but there are many more dangerous ones out there that could be used, like document.write, document.location, and other things that can access and change the DOM environment. Remember, when you're performing a DOM cross-site scripting attack, it's going to be run using the logged-in user permissions for that local system. So, if you're lucky enough as an attacker to have a system administrator who executes your DOM cross-site scripting attack, guess what? You now have access to that system as a system administrator too. Now, for the exam, let me give you a couple of quick tips. First, anytime you're looking at a log snippet or captured URLs that have the script or any kind of JavaScript inside of them, it's most likely going to be a cross-site scripting attack that's going to be the right answer for that question. And second, if you see something with document.something in it, like document.cookie or document.write, this should tell you it's a DOM-based cross-site scripting attack because it's affecting the document object model of your browser. If you keep those 2 tips in mind, you'll do great on the exam. Now, we're going to discuss cross-site request forgery attacks, but before we do, we need to quickly cover the concept of session management, because session management is a fundamental security component in our modern web applications. Session management enables web applications to uniquely identify a user across a number of different actions and requests while keeping the state of the data generated by that user and ensuring it remains assigned to that particular user. For example, right now, there are hundreds or thousands of people logged into my site at deontraining.com, all trying to take their courses. Now, they're all doing this at the same time, so we need to have a way to be able to track which users are doing which courses and which items in those courses. So, when you log into my website needs to keep track of your actions and know which lessons you're currently watching. It also needs to know which quizzes you've taken and all of your different actions throughout the course. And as you conduct those different actions, we need to store the results of that in our database so when you log in next time, you can resume the course at the right place and not lose all your progress. Now, as a developer, we can do this by using our own server-side tracking using our databases, or we can rely on cookies located on your client device. Now, in the first web applications, cookies were heavily used for tracking user actions because HTTP is by default a stateless protocol. This means that the web server doesn't preserve any information about the clients or their actions. So, in the good old days, if you wanted to store information about your client, you would simply store it as a cookie on that user's computer. A cookie is essentially just a text file that's going to be used to store information about a user when they visit the website. That cookie is going to be created when the server first sends the HTTP response header with that cookie over to the client. Then, any subsequent request headers that are sent by the client back to the server should include that cookie with the most updated information. Cookies can be either persistent or non-persistent. Now, a non-persistent cookie is also known as a session cookie. Session cookies reside in memory, and they're used for a very short period of time. When the browser is done with that session cookie is going to be deleted. But some other cookies are more persistent, and those cookies will be stored in the browser cache until they're either deleted by a user or they expire. For example, if my website uses cookies to track your movements and they're set to expire after 7 days, those would be considered persistent cookies. If you finished your work today, but you came back in 3 days, the cookie remembers where you were and it brings that progress back. On the other hand, if you left for 2 weeks, when you come back, the system might think you're a brand new user because your cookie is already expired after you were gone for 7 days. When dealing with cookies, those cookies need to be encrypted and secured because they could contain sensitive information in them as well. All right, now that we have a little background on session management and cookies, we can move into session hijacking. Now, session hijacking is a type of spoofing attack where the attacker disconnects a host and then replaces it with his or her own machine by spoofing the original host IP or using some other takeover mechanism. For example, a lot of session hijacking occurs by taking cookie theft or modification of those session cookies. Now, if the attacker is able to steal the session cookie, they can take over the session as the already authenticated user. Now, another form of session hijacking focuses on session management that's conducted using a database, and this database will assign a randomized session token to each user. If the randomized scheme is not truly random in nature, it'll create tokens that can easily be guessed by an attacker, and this means they can predict your session and take over the already authenticated session by guessing your randomized token. Session prediction attacks are simply a type of spoofing attack where the attacker attempts to predict the session token in order to hijack your session. To prevent session prediction attacks, the session tokens need to be generated using a non-predictable algorithm, and they need to be truly randomized. That way, the session tokens won't be able to be easily guessed. Also, those session tokens should not reveal any information about the session's client. Instead, session tokens should be a one-time use ticket for the duration of a given session. All right, now that we've established some background in session management and session hijacking, we can move into our discussion of cross-site request forgery attacks, also known as XSRF. Now, a cross-site request forgery attack is a malicious script that's going to be hosted on an attacker's site that can be used to exploit a session started on another site within the same web browser. For this to work, the attacker needs to convince the victim to start a session with the targeted website. Once that occurs, the attacker can then pass an HTTP request to the victim's browser and spoof this as an action on the target site. For example, if you're logged into your account already, the attacker might attempt to use a cross-site request forgery to change your password or your email address for that account. Cross-site request forgeries can be disguised in a lot of different ways as well. For example, cross-site request forgeries can use things like image, tags, and other HTML coding techniques to hide themselves. The scariest thing about a cross-site request forgery is that they can be accomplished without the victim necessarily even having to click on a link in order for that victim to be exploited. For a cross-site request forgery to work, the website must have a feature that could lead to unauthorized access, something like a forgot my password reset feature. And the site must rely on cookies for authenticating users and use predictable patterns for session management that can be guessed. So let's take a look at a real-world example of how this might play out. First, let's assume the browser is already authenticated to the target site, in this case, the victim's bank. That cross-site request forgery will then try to steal the valid session token from that victim's browser. For this example, let's assume there are 2 tabs open in the web browser. One is the attacker's website, and the other one is your bank. Now, you've already authenticated to your bank, but now you've also connected to the attacker's website inside this new tab because you clicked on a link in a phishing campaign or another social engineering scheme. Now, the attacker can use a cross-site request forgery attack to try to manipulate the session with your bank because your browser is already authenticated to that site and they can attempt to take over that session inside the other tab. So, how can you prevent cross-site request forgery as a defender? Well, let's say you're working for the bank and you want to make sure that nobody is going to perform this against your customers. What can you do? Well, first, you can ensure that user-specific tokens are used in all form submissions to prevent cross-site request forgeries. This is an action that your web developers would take as part of their secure coding and best practices. Second, you can add randomness and prompt for additional information whenever a user tries to reset their password, or you can require two-factor authentication. Third, you can require the user to enter their current password whenever they're trying to change their password. This would actually stop a lot of cross-site request forgery attacks because they usually try to change a user's password without the user knowing it in order for the attacker to take over that account. Now, for the exam, remember that if somebody is trying to get a victim to unintentionally carry out an action on a website, this is normally going to be a form of cross-site request forgery. This most often occurs by trying to get the victim to do some kind of unknown update to their default email address or by changing that user's password. So keep that in mind for the exam.